What we're going to do today is we're going to continue on graphing and identifying quadratic functions. But what we're going to use is exactly what we did right here. Exactly this. But instead of our friend the absolute value, we're going to be talking about quadratics. So we're going to take all this information. What's the vertex of my quadratic? What kind of, does it reflect? Does it stretch out? Does it compress? Etc. So let's interpret down here. Notice this is exactly the same function except one change. So let's see what we have here. Number one, we see clearly that it is a quadratic function because of the square. So instantly I know that it's going to end up being something like this. It doesn't have to be exactly that shape. A parabola, it could be reflected upside down. So our goal for this problem is we're going to identify the vertex, the axis of symmetry, the domain and range, and something called the max and min of the function. All right, so first off, remember that HK is my vertex. And so H is going to be the opposite of what I see inside, right there, opposite there, and then exactly what I see right there. So there is my vertex. There is my vertex. Now, so based on the negative in the very, very front here, this negative right there, that tells me that it opens downward. So because it opens down, so like so, we know that my vertex is going to be a maximum. Why? Why do I know my vertex is a maximum? So what do we see? We see that my minimum value, or excuse me, my maximum, what's the highest the function ever gets? Well, the highest the function ever gets is right here. It gets to a -4. It goes up, 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 up. At -4, it starts to drop back down again. So in this case, what's my minimum? Excuse me, my maximum? My maximum is y is -4. Or I can just simply say -4 for the minimum. Excuse me, maximum. All right, so depending on the direction, depending on which way this function opens up, that tells you whether it's a minimum or a maximum. One other thing we haven't mentioned yet is the vertex we already did, the axis of symmetry. The axis of symmetry. So all we have to do is take my -1 there and turn that into my line. So axis of symmetry, x equals -1. What else? There's one other feature that I haven't mentioned yet. One other feature. Well, but we haven't done domain and range yet. But what other feature here? If I were to describe it, does it stretch, compress, or stay the same? So it does stretch by a factor of 2. In other words, it gets a little bit tighter as it flips upside down. All right, the last things we want to do is also mention what the domain and the range are. The domain is what kinds of numbers am I allowed to put in? Is there any number that I'm not allowed to square? Because effectively, that's what I'm doing. Are there any restrictions on the square? I'm going to have all real numbers right here because there's no restrictions on a square. However, after I square numbers, so this one says I'm going to have a number, I'm going to square it, I'm going to flip these things upside down, etc. So this part right here, actually, this part right here tells me what kinds of restrictions I'm going to have on my output. Because I flip my function, and the highest it goes is -4, like we determined earlier, then my range is going to be less than or equal to -4. Now we could graph that and look at it just like we did with the previous problem. We can graph it and look at it and see that's the tip, so that's the highest it goes. So my domain would be all numbers this way, but my range would be only the numbers that are -4 and below. All right, so now let's spend some time graphing, and I've provided the steps right here for how we can use vertex form. Remember, if all else fails, if ever you're asked to graph, you know what you can always make? A table. If you make a table, you will always get a graph. Now, the table sometimes is going to be, might not hit the most important part like the vertex or something, but a table is probably your safest bet if you are completely lost. Just always make a table. All right, but first off here, let's go ahead and we want to do the graph. And remember, this is the parent function right here. So this function is my parent function, which means that is just y equals x squared. So when I make my decisions, it's going to be based off that. How much is it shifted away from that? How much is it stretched, etc.? So let's see here. Let's interpret this function. What are some things that we know? So my vertex is -2, 3. So I can actually plot that right now and just come over to here at -2, +3. -2, +3 puts me there. And that's just a coincidence. It's near the line, so it's not necessarily, or excuse me, the curve, so it doesn't necessarily have to fall anywhere near the curve. By the way, is this one a maximum or a minimum? Based on this right here.
Minimum.
It is going to be
A maximum.
a maximum. Why? Because we know that it opens down. It actually feels counterintuitive, right? Because the negative, you think negative should mean it's a positive, like it's a good thing, so it's your... or negative is a bad thing, so maybe that's your minimum. But in this case, it's opening downward. Okay, so we do know it opens downward. We also know that the axis of symmetry is along this right here. That's going to be important as we are going to plot an additional point here. All right, so we plot the vertex and the axis of symmetry. That's step 2. We just did that. We also know it's going to open downward. And let me just mark my axis of symmetry, x equals -2. Now we're going to plot 2 more points. And actually what we're going to do is only find 1 more point, and we're going to bounce that off the axis of symmetry. So how do I find 1 more point? Well, notice, since it opens downward, I'm going to end up going in this direction, right? And since this is where the middle of my function is, so where my axis of symmetry is, I'm going to choose numbers that are on either side here. Like, for example, I could choose 0. I could choose -1, -3, -4. But I probably would not choose 5. Because remember, when we square things, it gets very big very quick. Or in this case, very small very quick. So I'm going to choose, let's just choose maybe that one there. -1. Or I could choose 0. 0 probably is going to be easy. Let's see 0 and see what happens. So g of 0, when I substitute in 0, this is what I get. -2, 0 plus 2, all squared, plus 3. So -2, I went ahead and skipped a step. 0 plus 2 is 2, and I squared that to get 4, plus 3. And this ends up giving me -8 plus 3 is -5. All right, so that works out pretty well. In other words, when I go to 0, it's at -5. Now, what's the axis of symmetry tell me? It tells me that 2 away from the axis this way, 2 away this way, the axis of symmetry says it's 2 that way. So you don't have to even do any more arithmetic. You just plot the other point because the axis of symmetry tells me it reflects on the other side. So now I have to try to make my curve nice and pretty. And I'm going to mess up, no doubt. So that's where my eraser comes in handy. So I have to fit the curve so it comes up this way, curves down, it comes through, and draw my arrows. All right, in our final moments of class here, what we want to now do is write a quadratic function from the graph. So now we're going backwards. We have the graph, and now we want to go and substitute things in here. So step number 1, we're going to find the vertex, identify it. Step number 2, we have to find out what A is by doing some arithmetic. And then step number 3 is put those 3 things in. The x and y of the vertex, or the h and k, and the A. So first off, over here, identify what my vertex is. This is 2, positive 3. So this part is just mental, but I'm going to write it down for now for you to see. 2, 3. Now, step number 2 is I'm going to choose another point and substitute all that stuff in. So find a nice little point here that works here. So notice, this is a nice point that works. This is a nice point that works. 4, 7 is a nice point that works. So any of those blue points are going to work. It doesn't matter which one. I'm going to choose this one right here, 3, 4. So now here's what we do. We plug in the 3, 4 has to go in to the x and the y. And the 2, 3 is going to go in to my h and k. Because I already know my hk, and I'm temporarily going to say, well, if 3, 4 is a solution, let me plug it in and see what I get. All right, so there's my 3. I do not know what A is yet. Here's my 3 minus my 2 squared, and plus finally my k, which is 3. Now that all my things are substituted in, good, now that we've substituted in my 2 points, 1 solution and 1 vertex, I just go ahead and simplify where I can. So here, 4 equals A, 3 minus 2 is 1, and 1 squared is 1. Add 3. And now I'm going to subtract 3 from both sides to get 1 and multiply together. So A is 1. Yay! So now here's what I have to do. I have to go back to my basic vertex function, but this time A is 1, and my H is 2, and my K is 3. And there we go. This here is my answer. Notice that there is a little hidden one right here that we don't need to even write, but that is substituted in over there, and my HK was substituted in there. And that's it.